So we're moving on to this standard ARCH.7.RP.A.1.7.1d. The learning target is I can compute unit rates associated with ratios of length and area, semicolon, with ratios of fractions. So let's remember first to define area. Remember the size inside a flat shape is what we're going to find, and area is equal to units of length multiplied by units of width. The formula is area equals length times width, but in 7th grade we are switching over from x as a multiplication symbol to this little dot. So you will start to see area equals L dot W. Also area equals, A equals L dot W, shortcut for area. Also A equals the quantity, so with parentheses, it's pronounced the quantity of length times width. That represents multiplication. Okay, so define unit rate. So you need to have this written down, that it is a ratio with a 1 in the denominator. Example 60/1, 2/3/1, 8/1. Those are all examples of a unit rate. A ratio are two values in different units of measurements being compared. So if you have 60 miles per 1 hour, that's a ratio. To contrast that to a fraction, which looks like a ratio, but remember that two values of the same units of measurement are being compared, where the numerator is actually part of the denominator. That's what defines a fraction. So a cup, which has been divided into 4 parts, whereby you seek one of the 4 parts, would be 1/4 cup. It could also be written 1/4 over 1. 1/4 of a cup over 1 cup. Okay, sorry, that's part of the next page. Let's move on. So to work on our learning target, comparing, computing unit rates associated with length and area, we're going to look at these two rectangles, and we discovered that the length of the first one is 10 and the length of the second one is 5 squares. So we have 10 over 5, and if we want to compute a unit rate, we would say that we need to get to 1 in the denominator. So how would we do that? By division or multiplication? We're going to divide. 5 divided by 5 is 1. Now, to have this be a unit rate, we need to divide 10 also by 5. The same scale factor. So 10 divided by 5 is 2. So the unit rate associated with the length is 2 over 1, which equals 2. Also equals 2. Moving on to ratios of area. Remember, area is length times width. So the length is 10 here. The width is 8. So 10 times 8 is 80 for the area of the first rectangle. And we're not putting square units right now. We're just looking at the numbers so that we can focus our attention. The area of the second rectangle is length 5 times width 4, so that's 20. So you can take 80, divide it by 20 to get a unit rate for the area, or you can just divide by the same scale factor, because you want 20 divided by 20, you want 1 in the denominator for a unit rate associated with the areas. And 80 divided by 20 is 4. So our conclusion is that when length is doubled, the area is quadrupled. And this is a pattern that stands anytime you want to find unit rates associated with two figures in regards to length and area. Now, concerning unit rates associated with fractions, we'll just remember that 1/4 cup, it's not really a unit rate, because remember, a unit rate needs to have 1 in the denominator. Now, if you just create a 1 in the denominator, you're still referring to 1/4 cup. However, with a different example of a fraction, for example, if you had 6/12 and you wanted a unit rate, you still need to get the 12 to be a number 1 in the denominator. So if you divide by 12 here and here, 12 divided by 12 is 1, 6 divided by 12 is a half, or 6/12 reduced is 1/2. So we're not referring to any real world context at this point. We're just looking at fractions that can be associated with a unit rate if needed. Let's look at an example, real world problem. A water hose filled up 1/7 of a pool after 1/10 of an hour. At this rate, how many hours would it take to fill the pool? So what you need to recognize is you want a unit rate is your goal. So first of all, in a real world problem, you need to know what you're talking about. So we're talking about filling a pool in a certain amount of time. So we know that we need pool and time. Well, which one goes in the numerator and which one goes in the denominator? Well, the fact that you want a unit rate means you want 1 of something. 1 of something. And it already asked you that it wants to know how long it takes to fill the pool. So you want 1 pool is your goal. You want 1 pool in the denominator. So then you know that time goes up here, and they gave you time in hours. So you're going to go ahead and put all of that now, fill that in. So this will be what they gave you. So they're telling you that a water hose filled up 1/7 of a pool. So you have 1/7 here after 1/10 of an hour. And so now you have a rate because they told you at this rate. Now, how many hours would it take to fill the pool, 1 pool? So remember a unit rate. How do we get from 1/7 to 1? Do we multiply or divide? Well, if you look at the fraction 1/7 and the reciprocal, 1/7 and then you flip it, 7/1, you know when you multiply the reciprocal of a fraction, you get the number 1. Because you get 7/7, which is also equal to 1. Or 1 times 7 equals 7, and 7 times 1 equals 7, so it also equals 7/7. But it's easier to reference a fraction multiplied by its reciprocal as 1. So 1/7 times, multiply by the reciprocal, 7/1, will give you 1 pool. Now you multiply by the same scale factor. 1/10 times 7/1 gives you 7/10 of an hour. And that is the solution to this problem. So in this case, we have solved the problem, and that's the end of our lesson.